Hey there. Welcome to episode 9 of Brewing Better Java. I'm Anne Plessé with Azul, and today we're talking about maximizing efficiency in cloud-native Java applications. We're going to unpack how a high-performance Java runtime can help you reduce cloud waste and deliver more performance gains for your applications. With me today is John Ceccarelli. He's our Senior Director in Azul's product team. Welcome, John.
Good to be here. Thank you.
Awesome. So before we dig in, I want to take a step back for our audience and give them some visibility, John, to how we came about curating the content for our episode today.
Mm-hmm.
And that really falls into two common use cases or challenges that we solve for our customer base. So the first one is really around, okay, I'm getting ready to lift and shift my monolithic applications written in Java, right? And to the cloud. And where does a high performance Java runtime really fit as a part of that effort on my checklist? And the second use case or common challenge is really around I've lifted and shifted my application, and now I need to right size it for cloud consumption and compute consumption, right? So, but I know that many of our customers find that traditional Java runtimes available in the market are problematic in terms of application stability and often lead to over provisioning. So those are kind of the two use cases that we're going to focus this episode on. And so let's go ahead and dig in here, John. So what is a high performance Java platform and why does it matter?
Okay. Sounds good. Yeah, let's dig in. So, right, when we talk about Java, people think Java is Java, right? And most people, when you think about Java, they think about the Java language. So when you think about what's the next release of Java that's going to come out, you're thinking about what cool new language features are there going to be for my developers to be able to play with. But just as important as the language is the JVM, which is the Java runtime that is underneath that actually writes all those, it actually runs all of those great programs that you write in Java.
Right.
So let's take a look at it a second. What do we mean when we say Java? So at the heart of Java, there's the OpenJDK project. So Oracle open sourced Java or Microsoft, some microsystems did, I think.
Right.
And so the OpenJDK project contains the source code for all the Java language, the modules and stuff. It contains the source code of what's kind of the default implementation of the Java virtual machine. And the Java virtual machine, or JVM, that's the runtime that your programs run on top of. But unlike a lot of other open source projects, right, OpenJDK doesn't really have builds of the thing that it hosts the sources for. It has some builds, but nothing you would actually deploy in an enterprise setting, right? So for that, you've got a lot of vendors, more than ever before, out there building various versions of these JVMs. And most of them are what I like to call vanilla builds of OpenJDK. So they are exactly the same as OpenJDK in every way, right? In every response. And they're supported to various degrees, right? And some of them are free, some of them are included in various clouds, and some of them are paid. So of course, Microsoft has its builds of OpenJDK, Red Hat has its builds, Corretto has its builds. It's important. People sometimes think, Corretto is optimized to run on AWS. There's some language around that out there. They have done some stuff, but for the most part, the Corretto team just wants to make sure that if you move your app from Oracle Java onto Corretto, that it runs exactly the same. That's the value prop. And of course, Azul has the Zulu JDK and in our platform core offering, right? And then, but when you go outside of the vanilla builds, whose whole job is to be exactly the same, you get into the territory of high performance Java platforms. And the two most popular ones on the market, there are some others, but the two most popular ones are definitely Azul Platform Prime and its Zing JVM, and Oracle Graal VM. And these are JVMs that have been built and to behave differently and to behave better, right? And we'll talk about what that performance means, I think, a little bit later in this call. Another interesting thing is that while Azul Platform Prime starts with OpenJDK, it's based on OpenJDK, and then we just switch out some of the components for more optimized versions. Oracle Raw VM is actually a complete re-implementation on a completely different code thing. They're both TCK certified, which means they're both are certified to run everything that is in the
Not
job.
proprietary, right?
You don't have to recompile, you don't have to change any code to run on them, right? But it's just interesting to see like the different approaches that was taken.
Okay. Cool. All right, so let's switch gears here, John. So what are the practical performance use cases and what results can we expect for business critical applications written in Java?
Right. So when you think about performance, most people just think about speed, right? They think about, okay, I called that REST API. How quickly do I get my return? Do I get my response back? So that's what people think about performance. And obviously, there are lots of industries where that is incredibly important. So algorithmic trading, right? That is just the most important thing you can have with algorithmic trading. And things like fraud detection, right? So MasterCard, who, is one of our big customers, they needed to make sure that, every transaction that their fraud detection came in under a certain amount of time. So those are the ones that you think of a lot, but performance has lots of different characteristics. So one is definitely, yeah, sure. How fast can I get my response to my request? But another one is how consistently are you going to respond to my requests over time? So not just how fast is a single request, but are there any outliers? Is it hiccuping? Is it stalling? Is it, because even 0.001% of your traffic having a bad result can, in a lot of businesses, be very, very harmful to your business. So there's consistency. There's, you run fast consistently. There's how quickly you get to speed. So startup and warm up, two very important things, especially cloud native applications that have auto scaling going up and down all the time. This has become really a focus for a lot of folks. You have carrying capacity, right? So how much work can one server do before I need to scale out other servers, right? So that's very much a consideration. So and then you also just have how many resources does your server take, right? So for a given workload, right, how much CPU, how much memory are you going to take? Since so much of the cloud model is, resources over time, right? You're being charged by the hour on CPU and memory for the most part, in the compute world at least. That becomes really, really important in how much it costs to run your business, is how much, can your JVM handle your traffic with less resources? Yep.
Yeah, you bet. All right, so we've talked a lot. Go ahead and forward the slide, John. We've talked a lot about just what a high performance JVM is and some of the use cases. And it's funny because as you're talking, I'm actually getting DMs from some of the folks here. So, and they're asking me to prove it. So you and John are making a lot of promises as a part of your conversation. So we're going to do just that. So Azul actually has a Java engineering performance lab. And for about 4 years, that lab has benchmarked our runtime Zing against OpenJDK. So we actually publish benchmarks out to the industry. On average, we found over the past 4 years that Zing, our runtime, Azul Platform Prime, is about 36 to 37% faster than OpenJDK. And the way the lab works is really on 2 dimensions, right? So we'll benchmark every long-term release. So Java 8, 11, 17, and 21. And we'll also have a look at how fast those versions are, even between security releases, because anytime there's a security patch, there's an impact to the code base, and that can impact performance. So the dimensions we look at are across all of the long-term releases. And what we found is that consistently, OpenJDK stays relatively flat the last 4 years in terms of performance against our baseline, whereas Zing actually improves performance between releases. is, right? And you don't have to upgrade to get more performance, right?
Right.
And I mean, the report that we actually published focuses a lot on Java 17, which is the most widely deployed version in production workloads today, as well as 21. So anybody who's listening, who's looking, considering upgrading to 21, Zing may be a better option because of the performance gains, right? So, and then before we move forward, John, I want to talk about the second dimension that our lab tests against, and that would be working with Azul's customer base. Now, you mentioned MasterCard, right? So we actually published our performance results with MasterCard and Priceline, right? So Workday. So we actually work with world-class site reliability and performance engineering teams, and we share our results with them so they can continue to optimize in terms of performance. For Workday, that means they can deliver their HR and SaaS services with a lower cost to serve their customers. And you mentioned, of course, MasterCard with fraud detection. And we also work with the world's largest e-commerce platform, to help them with their site reliability. So those are the two dimensions across different releases, and then obviously with our customer base, which does include high performance trading companies. So as well. So that's digital operating models. Let's dig into the second. The second side of the coin here, because when we started our conversation, I was talking about performance gains, but also reducing cloud waste. So, John, I'm going to throw it back to you. You authored our cloud cost optimization cookbook, which is a guide that we're going to publish within the FinOps community next week. Can you take folks through, if you want to forward the slide there, take us through exactly how Prime helps to reduce cloud waste? So how does it work? And what's the impact in terms of business reduction?
Yeah, and we talked about at the beginning of the webcast, we talked about lift and shift, right? And how can the high performance platform help with an application that's been lifted and shifted? And then how can it help going forward once you've got it on the cloud and you're starting to modernize it and so forth? And something you said there, I think, is very important. I'm going to go back a slide very quickly, which is a lot of the applications that are just getting lifted and shifted and are not getting modernized. It's either because they're too important to touch, you're afraid to touch it, or they're too old to touch, and that they're not important enough to touch. Right. But in both cases, a lot of times what happens is you're staying on you're prioritizing stability, right? And that usually means staying on a Java version. A lot of people stay on Java versions for a long time. Java itself, OpenJDK itself, is getting faster with every Java release. So Java 17 is faster than Java 11. Java 21 is faster than Java 17, and so forth, right? But you do have to upgrade to the new version of Java, right, in order to get those benefits. And as we all know, 17 to 21 is a lot less stressful, but like 8 to 17, that's a major effort, right? That's a major effort.
Nail biter.
And so to be able to get those incremental speed gains on an application that's been lifted and shifted, that's being kept on its original JDK version is very important. Now, and one of the ways that that importance shows up is better customer experience, better functioning of your app. But the other way that performance shows up is as cost, right?
Right.
So let's talk about the ways that we talked about performance at the beginning. We talked about speed, right? But we also talked about consistency. We talked about warm up, right? And we talked about how many resources you're utilizing.
Right.
So imagine, for example, that I have a fleet of 10 servers, right? And they're all running at, like, I've got some auto scaling rules say, when this thing hits 35% CPU utilization, I know I need to scale up more servers, right? So I'm running all these things at 20, 25%, usual CPU utilization. And then when my CPU utilization bounces up to 35%, I'm spinning up new servers, right? And I need, at that level, I need about 10 servers to handle all my traffic. Okay, that's great. So how can we get that down? How can we get that down to like 8, 7 servers, right? In general. And those are, so the first way you do it is um, by just spending less CPU on each individual request. If each request processes faster, that means it's using less CPU. That means that instead of getting, say, 10,000 requests per second through a server and not hitting my 35% CPU utilization, now I can get 15,000 requests through that server,
There
right?
you go.
More requests per server means less servers overall. And you're going to see this a lot. The way that Azul Platform Prime affects your cloud cost spend is primarily by reducing your horizontal scaling, right?
Okay.
And to a certain extent, reducing your vertical scaling, but primarily reducing your horizontal scaling. So we talked about faster execution means I can get more transactions through my server. I need less servers overall. But let's talk about, why am I pegged at 35%? Why am I purposefully wasting 75% of the compute resources I'm paying for?
Right.
Well, the reason people do that are for two reasons, right? One is because Java, like all programming languages, right? It is prone to some hiccups, pauses, stalls, so forth, those outliers we were talking about. And if you have, and so you deal with that by just reserving lots of capacity, right? To deal with those things. If you JVM is taking care of those things for you and is reducing it so that you're not having this weird spiky behavior, but you're getting nice and level behavior, I don't need to reserve that anymore. Now I can raise up from, say, 35 to 45, maybe even 50% CPU utilization, right, before I'm spinning off other terms. So using more instances per server, again, means I'm getting more transactions through each server, means less servers overall. And then the final way we do this is, everybody knows the main thing about cloud that saves you money is the elasticity and the ability to only pay for what you actually use, and the ability to spin up JVMs, magic out of the air, spin up servers when you need them, and then shut them off when you don't, right? And this all sounds very good. And your apps should be designed in this way so that you can elastically auto scale them. But even some of the most intelligent teams, some of the smartest teams that in the world, and we work with a lot of very smart people, are saying, no, I'd rather just leave that server on all day long than deal with starting it and stopping it and just pay the penalty. Why? Because Java, especially, much more than scripted languages like Python or Node, right? Java has a startup and warm up process that it goes through, where at the beginning when you start a new server, the first X amount of minutes, depending on your application, is going to have worse performance. And you have this curve of how quickly how well your responses are going over time, right? As it gets warmed up. And safe to say, both, lots of people have approached this from different angles. GraalVM has ahead of time compilation. They have that native image support. We have, at Azul Platform Prime, have things like Ready Now, have things like offloading the compilations to a separate service. And now we're starting to see Crack, which is a project, OpenJDK project that Azul sponsors, being taken up by more and more both framework providers and JVM providers. So it's very exciting. But needless to say, if I'm more confident that a server that I started is going to behave predictably, behave acceptably when I'm starting it up, then I'm going to feel more confident about auto scaling to meet demand rather than leaving things on all day long and just paying that extra price.
Awesome. All right, let's take it home here. So this has been a good conversation, John. So we talked about the fact that Prime delivers additional performance gains, and you also unpacked how Prime can help reduce cloud waste. So if anything that John and I have talked about today inspires you and you want to dig deeper, here's a QR codes. Go ahead and snap those, and you can download our performance report as well as your cloud cost optimization report, and use that data and use that content to help right size and improve performance for your Java applications today. So John, thank you for the conversation. Really appreciate it. And thank you for those who joined. And if you have additional questions, go ahead and hit John and I up on LinkedIn. We're available at any time. And thank you so much for joining us today.
Thank you, Ann. It's been great talking as always.
Got it.